Ladies and gentlemen, boys and girls, my name is Subrata Sarkar. I'm a mechanical engineer working in manufacturing industry since the last 22 years. Today I'll discuss one of my favorite topic, that is FMEA, Failure Mode Effect Analysis. This is basically a subject of reliability engineering. This subject is very typical with the technical people, mostly the engineers in different areas of industry. But there's a logic. Things can be applied to many different fields actually. Now, what is FMEA? FMEA stands for Failure Mode Effect Analysis. Through this process, actually, we can quantify the failure. Any failure is something, some structure, some machine, some equipment, and some components. So what is the possibility of the failure that can be quantified? And there are three things actually during this process to find that one is the severity of the failure, one is the occurrence of the failure, one how we can detect the failure. So these things can be quantified through this process, and then accordingly process improvement action can be taken and risk mitigation plan can be taken actually. And in this today's presentation, I'll discuss or cover what is FMEA, different types of the FMEA, different terminology in FMEA, the teams in FMEA, and how this FMEA it can be quantified, the severity, how it can be quantified, occurrence can be quantified. So these will the things all are covered actually. Now you'll find that in most of the cases we have enough time to fix up any problem, but we don't have time actually when the things are initiated. For example, say some machines, some equipment, some structures we give comparatively less time during this the design stage. Then we start immediately manufacturing or making it, instead of doing a lot of this analysis. And maybe after making this, the things got, after some time, some year, within not expected time period, the things got fallen or broken or got damaged. Some accident happens. Then we all have a lot of time to do these corrective actions and fix up the problems. So instead that, if we take the problem, this proactively analyze the problem, so that there is a rare chance to come actually. So FME is that area where actually especially the engineers need to focus actually. Recently, like there is one flyover is collapsed. It's very close to our place. The people in Kolkata, everybody knows it. So there are things actually when the things are designed at that time. This FME is one of the things, but there are a lot of other things in reliability engineering. So those things process can be go through during the design process, during the manufacturing of the process or building of the process. Even everything is done, then also there is a MFMEA, there is a things called maintenance FMEA. So by that also you can prevent the this type of sudden failure of the things. Now when FMEA actually came into industry or practice, FMEA concept was started by aerospace industry when this Apollo program are taken for this as for space craft signing. This is 1960, and after that then the second industry take this concept, that is the automotive industry, 1970. And there was this quality criteria for to be a supplier for automotive industry. That was like QS 9000. That was a standard. Like today we all have ISO 9000 system. That QS 9000, in that is an advanced production APQP we call this advanced product quality planning. They taken into this FMEA concept into industries practice, and nowadays other than automotive industries are also taken this FMEA process in practice to improve and to make their products more reliable to the customer, for the user. Now, in this what FMEA can do actually, if we say this, because it is a process only, it is nothing physical, but it's the analysis process or the reliability engineering tool by which you can identify the failure modes, you can identify the effects and the severity, what are the severity can happen this type of failure, you can identify the causes, you can identify the possible occurrence of such failure, and you can at the same time put some controls so that this type of failure will not come. You can quantify the risk associated for the same, and then you can make the this advanced action plan so that the disaster or the things will not come actually. Now there are basically 4 types of FMEA, but 2 types are mostly practiced in industry. First one is called the system concept, or the SFMEA or CFMEA. When some system is organized for making any new projects, so it is nothing related with the product or the process, and there is which mostly used in industry, that is the DFMEA, design FMEA, design failure mode effect analysis. Third one is the process. When something is design is done, but how the things will be manufactured, so there is a process actually for that, which is called PFMEA, process failure mode effect analysis. And when in industry also there is a maintenance. Suppose you have a lot of super fantastic manufacturing setup, but suddenly one of your key machine got a breakdown actually, so your production line got hampered, so everything is got collapsed actually. Though we have a lot of preventive maintenance planning and a lot of things, but there is a one thing called MFMEA, machine FMEA, which can ensure that your machine will not give any sudden breakdown. So these are the 4 areas mostly practiced. 2 areas, one is the DFME, one is the PFME. Now in FME has got 5 area components of the people. When it talks about the team for the FME, one is the champion or the sponsor, and then there's a team leader will be there for FME. Not necessarily both the 2 person will be same. There is a facilitator, and one is the recorder, one and then the core team actually. So this is the formation of the FME. You can see how this is going on. So champion provides the resource and support, and attends to organize the meeting basically, and recorder keeps these, whatever will be the inputs and every documents, they are supporting things are given. So this and core team is basically multidisciplinary, or we call cross functional team. So one from the design person, one from quality, one from maybe from the marketing, and one from some other department, one from this supply chain. So in this way, the core team formation occur. Maybe it's not a very big team for any projects. Maybe 6 to 8 person teams is good enough actually. And there is a team leader and facilitator. They are basically, role is basically watchdog. Actually, they will see the things are going, as per the process, or whether it is not going. But the team leader will not lead the things actually. He will make sure that everybody is participating actually. It's not that someone is leading. It will be different discipline will give their input, and everybody is participating. That's very important actually. Now in failure mode FMEA, there are a few terms. One is the failure modes actually. When this failure occur, the failure this effects actually. So after this failure has come, what can happen, the severity of the failure, and the failure mode causes, the probable causes of the failure, then occurrence rating actually. Like this type of failure, how many times it can occur? It occurs frequently, it occurs rarely or occasionally. So these are the things actually. This is called occurrence rating. So depending on the type of the occurrence, there is a rating number from 1 to 10, and the failure mode controls, and then detection rating. Suppose there is a failure that happens, but you are unable to detect how the failure occurs. So it is very dangerous actually. So failure is happen, but you can, if you give attention, you can detect actually how the failure is occurring. So in this way, the detection rating can be done. That is also from 1 to 10. And most important and conclusive, term in FMEA is the RPN, risk priority number. So RPN is a numerical value. RPN is equal to S into O into D. S means severity into occurrence into detection. So RPN number, so you will decide, and depending on the process, there is a standard RPM range, and if your RPM is crossed by this analysis, say allowable RPM is 200, and by this process you will reach to a 300 RPM, then you have to back to the process from the beginning. So what improvement can be done so that you can reach up to 200? So this is the process actually. Now, as I said, actually this is the process flow actually, step by steps when you do this FMEA. So what are the things that can be done? Like you have to first understand the customer requirement, then you brainstorm on this process, what are the failure modes actually, and then how you will tackle this failure mode, and what are the things action plan can be taken. So when this make the templates ready actually, then this FMEA, you are ready for making this FMEA. So first is determine the product or the process functions, then you determine the failure mode of the functions, then you determine the effects, then determine the causes, determine the control, then calculates, and finally you will reach to a RPM number. Now, the severity, suppose that is the defect in the product or the structure you are into this analysis. So if there is this type of failure has no effect actually on this, so you can, this is so none, low, moderate, high, and extreme. This is severity. So depending on, you'll put number from 1 to 10. So in this way you can put the severity. Suppose severity, this is like hazardous without giving any warning. So your failure will happen such a way that you will not get any warning. Suddenly there will be a catastrophic failure, or it will be collapse. So this is a very risky. So then you will give the number 10 actually for the occurrence. Now for this occurrence, you'll find that, say, the things will rarely occur actually. You'll say that here, very rarely, unlikely, it never happens, but there is but sometimes that your process of the product is such that this type of failure occur maybe in one chance is once in a year or once in a month. So depending on how frequently this can occur, so this is in this way you can put the number. So you can give a number, but in 1 to 10, and then the detection. Say the problem will come, but you are not in a position to detect, then it is very dangerous. So it is called, the control is not in your hand. So in this way you can put the very high risk, low risk, moderate risk. In this way you can give number 1 to 10. And finally, when you put this number for both severity, detection, and occurrence, you do multiply the severity to occurrence into detection, you will get a RPN number. So if this RPN number is say 200, and industry standard it is 150 needed, then you have to go back from the beginning to the process, and you do a lot of brainstorming so that what things process can be improved so that you can reach or reduce the number. So this is a process or the things actually. It is not making that, it is before doing the things actually. So doing this analysis, then you streamline what things can be done so that your risk priority number will be this, or that is within control. So if you find this presentation is interesting and informative, you can share with your friends and family or your colleagues, those who are especially in engineering fields. And if you have not yet subscribed my YouTube channel, you can subscribe my YouTube channels so that you can get the notification for my upcoming presentation. Thank you very much for your attention.